So in this video, we're going to talk about conversion factors and dimensional analysis. I'm going to go over how to create conversions using the SI prefixes that you've learned, how to deal with squared and cubed conversions, and then two types of volume units that we will need to know a conversion between. And then we'll use the conversion factors in simple dimensional analysis problems. So first, talk about what a conversion factor is, and then we'll talk about how to create them. All a conversion factor is a relationship between two things that are set equal to each other. So for example, I could say 3 equals 3. And while we know that this is true, right? So we're looking for a couple of things with our conversion factor to make sure that we're using the correct conversion factor. And is it true? So if I set these two things equal to each other, then we need to ask ourselves, is that correct? Is this side equal to this side? If two things are equal to each other, I can then put them on top of each other as a fraction. And what that really says is 1. So the goal here of conversion factors is to convert one amount or one measurement into another measurement, but without changing the actual measurement. So if I have my original measurement, I don't want to change the actual measurement. I just want to rewrite it in a different unit. So let's say my original measurement is in inches, but I want to tell you how many centimeters that is. If I multiply it by a conversion factor as a fraction, I get the new measurement but it's in a new unit. It's the same measurement. So it's the same length, for example. Right? I'm not changing the actual length or height. Like if I say, oh, what's your height in centimeters? You're not changing how tall you are. You're just changing how you say it. Or what's your weight in kilograms? If you weigh yourself in pounds and then convert it to kilograms, I'm not changing the weight. I'm just changing how I represent it. So the conversion factor as a fraction, which was really 1, we're really multiplying our original measurement by essentially, quote 1, unquote. And then we're getting a new unit here. So hopefully that makes sense. That's what we're going to be doing with conversion factors. And so what we're trying to do is get rid of the original measurement unit, get a new measurement unit out of it, and then really not change the real meaning of the measurement by just converting it, by just multiplying it by a conversion factor, which is two things that are equal to each other on top of each other, which really equals 1 as far as the meaning of it or the value of it. So that's just the basics of what we're doing or why we're doing the conversion factors the way I'm going to show you, which is to make equalities first. And what I'll do is so this is why I'm going to focus on creating equalities here in this first part, and then we use those equalities as fractions in dimensional analysis. But first, I think that creating the equality and going through and writing down exactly what is equal to what from the problem or from your memory or from an equation sheet or a conversion sheet that you're given, just writing that down is going to help you solve the problem. And so let's look at how we can write our own conversion factors as equalities. So first, the first type of conversion factor Let me just right here, right as right conversion of equalities for men as fractions in dimensional analysis. Now, you may be really, really good at dimensional analysis, and you've been working with dimensional analysis for a long time, and you don't have to go through and do this. But if you are just starting out, or if you notice that you're having a hard time with it, then I highly recommend that you write all of your conversions as equalities first. It's just going to help you organize information and solve problems in a way that is going to give you the right answer more likely than to confuse you. So first, let's look at the SI conversions. So to turn an SI prefix into a conversion, first, we're going to write the SI definition. The prefix is equal to 10 to the what? So I'll do an example. Centi means 10 to the negative 2, for example. So just writing the definition. Next step is going to be add a base unit to both sides. So because we have an equality now, this is true that centi is equal to 10 to the negative 2. These two things are equal to each other. So we're checking along the way to make sure that our equality is true before we go any further. Now, if I want it to remain true and I want to say centimeters, for example, if I put an M here, I have to put an M also here, right? Because it's an equality. If I do something to one side, I have to do it to the other side. So if I put in a meter on one side, I would have to put in a meter on the other side. And you can use any base unit. Second, we'll use a unit later in chemistry called a mole, liters, any base unit that you can think of, or even if it's a made up unit given to you in a problem somewhere, as long as it's the same on both sides, it's technically equal and you can use it as a conversion factor. And then the last thing that I like to do for these is put a 1 in front of the prefix side. And then another note here, 1 times 10 to the negative 2 is equal to 10 in the negative 2, for example, because sometimes you will need to know how to write it either way, like either in scientific notation. Also, if you change side of equality, change sign of exponent. That might be a note that comes in handy. Well, I'll give you an example of that in a second. I'll show you the different ways in which you can write centimeter conversion. So I'm just gonna add a 1 in front of the centimeter here. And that is good enough for me. Like if you're just wanting to solve problems for me, that's how you can write the centimeter conversion. Now, however, you may have learned your SI conversions a little bit differently, or you may move to a class where the instructor uses different conversion, and I don't want you to get confused. So you can say 10 to the positive 2 centimeters is equal to a meter. Now, what have I done here? I've switched the numbers. The 1 and the exponent, the power of 10 has been switched. When you switch an exponent to another side, you change the sign of it. So it's now positive 2 on this side. And 10 to the positive 2 is really 100. That's just what 10 to the positive 2 is. You could also say 1 times 10 to the positive 2 centimeters is a meter. We can also break this down into standard notation. We can say 1 centimeter is equal to 0.01 meter. That's the same as 10 to the negative 2. Or we can put a 1 in front of it. 1 centimeter is equal to 1 times 10 to the negative 2 meters. These are all correct meter to centimeter conversions. But if you're just looking for a quick and easy way to memorize all of your SI conversions, just memorize exactly what the letter means, put a unit on both sides. This got to be the same unit on both sides. So it says equal, and then stick a 1 in front of the prefix side. Now you have a conversion. It'll work for you every time. So go ahead. Write the equality. Conversion. For, let's do microliters to liters. So pause and do that and then come back. So our first step is to write the definition. The definition of micro, which is also MC, remember, is 10 to the negative 6. Now, this is one that you probably don't want to write in standard notation. Like I can write 100 pretty easily, or 0.01, but like 0.0000001 is a lot harder to write. So you probably want to keep this in the power of 10. The next step is to add a base unit. The base unit here, I'm asking you specifically for liters. So we're going to add a liter to both sides. So the question should give you some context as to what base unit you need. And then we add a 1 in front. And there you have your microliter to liter equality. So anytime I see microliters maybe in a question, I'll just go ahead and write that down, because it's helpful just to write down stuff as you think you might need it, instead of trying to figure out all at once in a problem. Here's everything I need, and I have to know that right now. Like you see microliters, cool, write a microliter conversion like this, just so you have it down. Maybe you don't need it in the question, but have it there, and that can help you organize information outside of your brain. So the next thing is we're going to do is look at squared and cubed conversions. So squared and cubed conversions can look really scary, but they're really simple to deal with. And so if you need to deal with a unit like centimeters cubed, what if I said like, write a conversion if we need to go from centimeters cubed to meters cubed, or vice versa. A lot of students get really scared of the cube here. Well, the first thing that we're going to do is write the normal conversion without the cube or the square. So we know 1 centimeter is 10 to the negative 2 meters, or 100 centimeters is a meter. Whatever you have memorized, whatever you're using, write your normal conversion without any cubes, without any squares. Then we're going to cube or square or whatever you're doing every number and unit. Every single part is going to get cubed or squared. And here, let me be a little consistent. So I'm going to say 1 cube, centimeter cube, 10 to the negative 2 cube, meter cube. Now I know that you may know that 1 cubed is just 1. However, what I found is that when students just cube like this, because 1 doesn't need a cube, they then also just cube this. And this is not equal. This is not correct. Because you forgot to cube this part. So my suggestion is to just cube the 1. I've also seen people do it like this, where they say, I'm going to cube the whole thing like this. And then what they forget to do into their calculator is cube this part here. So while this is true, it leads to mistake. So my suggestion, if you want to get it right every time, is just painstakingly put that little 3 next to every number and every unit. And then we can clean it up. And what I mean by clean it up is do the math for the numbers that are cubed. So for example, we know 1 cubed is 1 centimeters cubed. Now, 10 to the negative 2 cubed, when you have a power and you raise it to another power, you multiply these two numbers together. So this will be 10 to the negative 2 times 3 meters cubed, which is 10 to the negative 6 meters cubed. Now I have a cube conversion. And I would use it the way that I would use any conversion, which we'll talk about in just a second in our last portion. So go ahead and try it. Write the conversion. And again, this is the equality that I want you to do. Write the conversion for feet cubed and feet. Oh, sorry. Feet cubed to inches. Oh, wait, you don't know that one yet. So this will give you the numbers for it. Let's do feet cubed to inches cubed. And remember that 12 inches equals 1 foot. So try that. Okay. Have you paused and tried it? If not, go ahead and pause and try it. If you have already done it, then you can follow along. So first, we're just going to write the regular conversion between feet and inches. I know 1 foot is equal to 12 inches. Then I'm going to cube everything, or square. Sorry, this case is square. So we're going to square everything. 1 squared, foot squared, 12 squared, inches squared. And then we can clean it up. And you don't have to clean it up. Really, the cleanup is just for me. When I'm doing this, it's easier for me to want to do it in steps like that. If you're comfortable with your calculator, you can just write in 12 squared. Like, that's fine. You're not incorrect. But I know for some of you, maybe using the calculator in that way can lead to some error. And so doing it in steps might be helpful. So there's your squared conversion. See, not so bad. Lastly, let's talk about some
volume units. So we have two different types of volume units. We have a liter-based volume unit, like liters, milliliters, any liter, like microliter, centiliter, etc. And then you have length cubed or length based, right? And this is going to be meters cubed, centimeters cubed, inches cubed, feet cubed. These are all volumes, but they're based on a cubic length. There is one conversion that is helpful that you can memorize that's really easy to go between these two. And that is that 1 milliliter is equal to 1 cubic centimeter. Now, a cubic centimeter is equal to a cc in medicine. So if you say like, oh, it's a cc, that's the same as a milliliter, which may be something that those of you going into healthcare need to know. And so this is a really easy conversion if you need to go between a length-based volume and a liter-based volume. Just throw this equality down on your paper to help organize your thoughts. And then if I go from milliliter, I can go to liter to microliter. I can go wherever on this side. And then if I have centimeters here, I can go wherever on this side, right? If you have those conversions that you know in your head or that are given to you. So that's a good in between. Okay, so let's put some conversions together and some dimensional analysis. And then we're gonna have, I'm gonna have other videos with more practice with this. I'm just gonna give you the basics right now. So let's say, I'm just gonna show you with an example. If I measured out something and I said that thing was 40.1 centimeters, but I want to know how many inches that is. Okay. The first thing that I want to make sure that I have written down. Now you'll notice that in class and in lecture videos or in interactions with me, I'm always going to ask you to write stuff down more than you think you need to write things down, because that is going to help you process the information in your head by offloading some information onto your paper. And this is going to be really helpful with you with solving more complicated problems as you move farther into your chemistry career. The more complicated you think something is, the more you need to write down and not just keep inside your head. So instead of just thinking of the conversion in my head and then trying to do the math in my head and then trying to go straight from the question to an answer, I'm going to write down a few things to organize. Where am I going to start? Where is my ending or my unknown? And what are some conversions that I need to bridge those gaps to get me there? Sometimes the place to start is hard to find, especially if it's in a longer word problem. Here's a simple example. So maybe the first thing you want to do is write down what it's asking you for. What's the unknown? Here, it's asking me for inches. So I'm going to put question mark inches here next to unknown. So that means the other information is where I'm going to start. The start is 40.1 centimeters. Now, depending on the class that you're in, you may be given a centimeter to inch conversion, or you may have to memorize the centimeter to inch conversion. It is 1 inch equals 2.54 centimeters. And this conversion specifically, even though it's going between the metric system and the English system, is exact. So these are exact significant figures, meaning infinite significant figures. Oh yes, significant figures are something you have to worry about on top of all of this other stuff with dimensional analysis. So the next thing that I want to do is to make sure, do I have all the conversions that I need before I even start setting up dimensional analysis? Now, I've probably assigned you some sort of discussion or some sort of activity where you go and you try out how to set up dimensional analysis on a website, or you maybe remember that from a previous class. But before, I know you want to get to it, but before that, let's make sure you have everything you need before you start your puzzle. It's like making sure you have all the pieces of your IKEA furniture before you start trying to put it together. So what I like to do is, you know how in movies or TV shows when somebody's trying to solve a crime and they use string to connect like people and places and stuff, let's think about doing that with units here. So it's going to look kind of messy for a second, but go with me. So if I'm going to start with centimeters, I see I have centimeters here. Centimeters are connected directly to inches through this conversion. And inches are what I want. So now I can put my finger on centimeters and go all the way to inches, my unknown, without picking up my finger. If you can't do that on your paper, if you can't put your finger at your starting unit and go all the way to your unknown unit without picking up your finger, you don't have all the conversions that you need to solve your problem yet. And so you need to collect more conversions. Here, it's just a one step. In the next video, I will do more complicated problems than that, but we're just going to get the basics here. So how can I now convert this? What we're going to do is we're going to start with your starting, which is typically going to be a single unit. You don't want to start with the conversion factor. Let me show you why. If we start with the conversion factor, so let's say I want to say 1 inch over 2.54 centimeters, and I say I'm going to put that as a fraction. And I say, okay, what am I going to put next? Do I need to cancel out inches, or do I need to cancel out centimeters? Or did I write it wrong? Because I can also write this conversion, because it's equal, I can put either one on top. Which one do I use? Right? So you're kind of locking in this on top and this on bottom before you really know which way you need it to be. So I highly recommend that you don't use the conversion as the first step, because you're not going to know what comes next as easily, and it gets more confusing that way. So if you have an option for a single unit thing to go at the very beginning, put your single unit at the beginning. So here we have our centimeters, and we're going to put that first. Now you can write, and this, use this as my like scratch area over here. You can use fractions like this for dimensional analysis. It's really what this is. It's a fraction times a fraction times a fraction. Or what I like to use is, like, I call it the train tracks, but it's just a straight line down to separate them. To me, it saves some space, and it looks neater, and it's just what I learned first. So I'll probably be using this. Anytime you cross this vertical line, that means multiply across. Anytime you cross the horizontal line, it's division, right? So anything in the bottom of a fraction is actually being divided. Other people I've seen do like this, where the fractions are in parentheses. It's all the same thing. So you can use any of these, are appropriate, whatever works for you. Okay. So you can put this over 1 if you want to. I used to, when I was first learning this, I used to have my instructor would put it over 1, but make sure that you do not put a unit with it, because it's not 40 centimeters equals 1 inch or something like that. So I've actually gotten away from doing that because people try to put units under there. But again, this is one way that maybe you have looked at it in the past or you have learned it before. But no, that's the top of a fraction. So if I do the train tracks, I don't need anything on the bottom there. Because we don't know what it's equal to. So we don't know what to put on the other side. Now, when you use your conversion factor, what we're looking for is to check that our conversion factor is in fact equal before we use it, which is true. This is equal. Then we're going to place the conversion factor as a fraction so that the unit I don't want gets canceled and the unit that I do want is kept around. So thinking about that, let's look at another little sidebar over here. If I have 2xy over y, what happens to the y's? They cancel out, right? So the same thing is going to happen here. If you have two units on top of each other that are the same, they're going to cancel. So I want the centimeters to go away because I want my answers to be in inches. So I need to put the centimeters on the bottom of the fraction. So the number that goes with centimeters, so if I just say, hey, I know centimeters need to come down here. The number that you wrote in front of centimeters in your equality is the number that has to go in front of centimeters down here. You can't switch your numbers because now it's not equal. It's not 2.54 inches equal to 1 centimeter. That's not true. So whatever you write as your equality has to stay the same when you turn it into a fraction, like the number and the unit combination has to be the same. Now, the equal sign is going to tell you what goes on the other side. So 1/2 of the equal sign goes on the bottom of the fraction, and the other half of the equal sign goes on the top of the fraction. So if centimeters are going to go on the bottom, because I know I need to cancel those out, what goes on top is going to be the 1 inch, because that is what 2.54 centimeters is equal to. So you can only put two things on top of each other if they are equal to each other. And that's why I wanted you to write the equalities first, so you can tell what things you can put on top of each other. Now you can use them either way. You can write the 2.54 centimeters on top and the inches on the bottom if you need to. But in this case, we needed the centimeters to go away. So I need the 2.54 on the bottom. Now, once I have canceled everything I don't want and I have inches left, which is what I do want, I can now ready to solve. How am I going to put this in the calculator? I encourage you not to do 40.1 times 1/2. Like, don't put the fraction in the calculator. I don't think that is going to be the best use of both your time, and it's not going to help you understand what's really happening mathematically when you do that. So I wouldn't put that in the calculator like this. It's going to give you the right answer, but I want you to understand what you're doing when you are multiplying a fraction. Anything on the bottom of your whole dimensional analysis, let's say this is a long train tracks, any number that's on the bottom needs to be divided overall. So the best thing to do is to put any number on top is going to get multiplied. So if you want to include the 1 here, we can include the 1 times 1 because the 1 is on top. So any number on top is getting multiplied here. Any number on the bottom is getting divided. So that is how I would put this in the calculator. Now, if you know you don't have to worry about the 1, then you just do 40.1 divided by 2.54. Right? But don't worry about inputting the fractions into your calculator, because I want you to understand that multiplying a fraction is just multiplying the top number and dividing the bottom number. So this is basically what I get. I'm going to use my inches here. And then we're going to round for significant figures. So if I'm doing multiplication and division, what sig fig rule am I going to use? We're going to look at the number of sig figs. So 3 sig figs for my starting This one is infinite sig figs. This particular conversion is infinite sig figs because this is exact. Most of the time when you're going between an English system and the metric system, it's not exact. But you can, for some classes, make sure that you ask me before you do this. But in some classes, you can just assume that most conversion factors that you're memorizing, or that I give you, if I give you like an equation sheet or a conversion factor list or something, you can assume that they're probably infinite. But I will be specific and tell you, assume these are infinite sig figs. But this one in particular is always infinite, even if you're not making that assumption. So what's a smaller number, 3 or infinity? 3 is smaller. So we need 3 sig figs here. So I want my number to be 15 point something. The number that comes after the 7 is an 8. So we're going to round just the 7 up. So my answer is 15.8 inches here. I hope that makes sense. We're going to do more examples for sure in later videos. But go ahead and you can use this to get started and trying some homework.